Hello everyone, this is Ian from Ozone Engineering, and welcome to this video where we'll cover some basic techniques that you can use to visualize magnetic fields in Ansys Maxwell. For this demonstration, we will be using one of the built-in examples in the Ansys Electronics desktop. Because the topic of today's video is about visualizing magnetic fields, let's open up an example project that models one of the most common devices used to measure magnetic fields, a Hall effect sensor. The first thing to do after opening an example project is save it in another location. This will allow you to manipulate the file and save the changes you make to it. Next up, let's run one of these simulations. I'm going to run the second design in this project, the 3D magnetostatic simulation. This features a parametric setup that sweeps the variable angle from 0 to 30 degrees. What that'll do is rotate this wheel and give me field information every 2.5 degrees. For this part of the demonstration, I'm only interested in one of those angle values, so I'm going to disable this setup and go ahead and run the analysis. With the simulation complete, let's check out our fields. A great way to do this is by creating non-model objects. Non-model objects are regions of interest that we can use in our post-processing. They can be points, lines, planes, 3D objects, it's your choice. To make a non-model object, click Yes in the dialog box that appears when you try to create an object after a simulation has already run. And as a quick aside, you have the ability to select any object and turn it into a non-model object. This is an incredibly powerful debug tool because if your simulation is failing and you don't know why, you can go object by object, removing them from the model until you find the one that has caused your issue. Let's start by drawing a point. Click on the draw ribbon up top, click on draw point. And now I'm going to place this in the center of this permanent magnet over here. As soon as you click, it's going to populate in the model tree. Now you'll notice point 1 and point 2, very nondescript. I think it's good to get in the habit of naming these as you create them. This point 1 is in the Hall wheel, so I'm just going to rename it in the properties box. Arbitrarily, I like to name my points P dot Hall wheel. I'll go ahead and name the other one P dot PM for permanent magnet. That is what this object here is. Next up, let's right click on results. Under create fields report, let's make a data table. For the primary sweep, it makes more sense to me to look at the angle that we're at for this particular instance. We did not run the parametric analysis, so this will just be the only angle that we simulated, 0 degrees. Let's make sure the geometry that is selected is the permanent magnet point that we created, and we'll look at the magnitude of the B field. New report. And it has generated the magnitude of the B field at that point for us. Next up, we'll plot the B field on a line that goes through our objects here. To make it a little bit easier on myself, I'm going to orient top down. This will allow me to create a line that is centered with my Y coordinate and my Z coordinate at 0. I'll click on my first point and the second point, right click, press done. And your line has been created. Right click results again, field report, and this time we're going to create a rectangular plot. Make sure that your geometry this time is the line that you've created, magnitude of the B field, and new report. Whenever you plot fields over lines in this way, your x-axis will range from 0 to some number determined by the length of your line. If you want to start getting data points out of these curves, right-click, under marker, start adding a couple markers. I'm interested in a point here, 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 and here. If you want, you can export the resulting marker table. Marker, export marker table, and you can choose between a CSV or a tab file. Additionally, if you right-click under markers, you can create delta markers. This time, every time you click on pairs of markers, a row is added to this table. This row will give you information on your delta x, your delta y, and the slope of the line that intersects these 2 points. It also generates a regular marker table for all of those points as well. Next up, we'll create a couple planes to plot our B field on. I'll change again to a top-down view and make a new relative coordinate system in the center of my Hall effect sensor over here that I'll then use to create a rectangle. With the rectangle created, all I have to do is right-click the object under Fields, B, click on Mag B, and Done to plot the magnitude of my B field in that plane. Let's do the same thing for a rectangle in the XZ plane. Double-clicking on the color key will give you a lot of options on your scale and different customization for your plots. If you really want to see what the action is, experiment with a decibel scale or a logarithmic one. Just like with the 2D rectangular plot, we can use markers here to get this field at various points. Right-click Field Overlays, Fields, Marker, and click on Add Marker. Now you can start clicking around, and as before, it generates the marker table for you. And similarly, you can right-click on Field Overlays, Marker, and you can export this marker table again as a CSV or a tab file. And finally, let's look at plotting on things that are not non-model objects. Simply choose whatever you're interested in, right-click, Fields, and choose the quantity that you're interested in. A lot of times you're going to want to plot on just the surface only, but there are plenty of times that you're going to plot the volume as well. So let's go ahead and demonstrate this. I'm going to delete this for now, and I'm going to create a 3D object. I like to make these boxes mostly transparent. So with this created, I'm going to select it, click Field Overlays, Fields, B, and this time B Vector. I'll select Done, and a vector plot is created within the volume that I've selected. You can go ahead and come through here and start messing with this to make it a little bit more easy to understand. Alter the scale, the spacing of the vectors, etc., until it's something a little bit closer to what you're interested in it looking like. If the vectors inside of a volume are a little bit too noisy for your tastes, you can also plot those on a plane. I hope you found this video on the basics of visualizing magnetic fields in Maxwell to be helpful. In the next video, we'll open up our field calculator and look at how to plot individual components of our fields rather than just the overall magnitude. I'll see you then.